Hey, welcome back. Today, we're going to get right back to basics and tackle a question that seems simple on the surface. What exactly is a natural resource? As you're about to see, the answer is a whole lot more complex and, well, a lot more human than you might think.
So to get us started, let me ask you this. Picture a rock, just sitting there in the ground. Is it a resource? Your first instinct might be to say, sure, of course. But the real answer? It totally depends on us.
Okay, let's start with the official textbook definition. A natural resource is a naturally occurring substance that we consider valuable in its unmodified form. Now, the key phrases here are naturally occurring, that's pretty straightforward, and considered valuable. That second part, that's where things get really interesting.
This quote absolutely nails it. The economist E.F. Schumacher said it perfectly way back in the 70s. Resources are defined by man, not by the nature. You see, a substance only becomes a resource when we decide it has value. Nature doesn't label things for us.
So, what gives something value in our eyes? It really boils down to two things. First, we have to have the knowledge and the tact to actually get our hands on it and use it. And second, there has to be a demand for it. People have to want it, now or in the future. If you don't have both of those, that rock is, well, it's just a rock. Right. If those two conditions aren't met, a substance is just what we call neutral stuff. It's there, it's part of the planet, but without our human ingenuity and our needs, it doesn't have any resource value. You know, for most of human history, crude oil was just weird black goo in the ground. It was neutral stuff until we figured out what to do with it.
So here's the game plan for today. We'll first make sure we're solid on what defines a resource. Then we'll get into how we classify them. We'll take a deep dive into stock resources, the ones we can run out of, and then flow resources, the ones that are supposed to keep coming. And finally, we'll talk about the critical breaking point, when those endless resources might not be so endless after all.
Okay, so we've pretty much established that a resource isn't just a thing. It's a mix of what nature provides, what we know, and what we need. It's a human concept. All right, moving on to Section 2, Availability and Classification. Now that we've got a handle on what a resource is, let's figure out how we organize them. How do we sort them based on whether we can even get to them? Availability really comes down to two big things. First, you've got the physical reality, where the resource is, how much of it there is. Second, you've got the human factors. Do we have the money and the technology to actually get it and use it? We can't change where nature put the gold, but we can definitely change our ability to dig it up. One way we can sort resources is by who owns them. Some things, like the air we breathe or outer space, are pretty much open access. They belong to everyone and no one. Others might be common property, privately owned, or controlled by the government. This whole framework is super important for figuring out who gets to use them and who's responsible for managing them. But the most common way to classify resources, and the one we're going to focus on, is all about the timescale of replenishment. We basically split them into two huge buckets: non-renewable or stock resources, which are for all practical purposes fixed in supply, and then renewable or flow resources, which are supposed to renew themselves pretty quickly. Okay, let's dive right into that first bucket, stock resources. The absolute key thing to remember here is that from a human perspective, what we have right now is all we are ever going to get. These are things like fossil fuels, minerals, even land itself. I mean, they took literally millions of years to form, so their supply is fixed. We can't just whip up a new batch of crude oil or copper in a lab. The tank is finite. Now, even within this stock category, we can break it down further. Some of them, like coal or oil, are consumed by use. Once you burn them, poof, they're gone forever. But others, like metals, think aluminum, are recyclable. We can recover them and reuse them again and again. But, and this is a really important but, there's no free lunch, even with recycling. It's often a super energy-intensive process. And think about it, where does most of that energy come from? Yep, usually from the other kind of stock resource, the fossil fuels that get consumed when you use them. It's a tricky cycle. Now let's totally shift gears and look at the other side of the coin, flow resources. These guys operate on a completely different principle. It's not about a fixed amount, it's about a constant renewing cycle. So flow resources are the ones that are naturally renewed in a short enough time to be useful for us. We're talking about solar radiation, wind, tides, the water cycle.
The sun comes up every day, right? The wind blows. They are in a constant state of flow. For a lot of these, we operate in what scientists call the non-critical zone. I mean, the flow of sunshine or wind doesn't depend on what we do. Sure, we can mess things up temporarily, like polluting the local air or overpumping a river, but if we back off and control our exploitation, their quality and flow are usually restored, naturally and pretty quickly.
All this makes them seem almost infinite, incredibly resilient. But that leads to a really critical question, doesn't it? Can this natural, self-healing flow actually be broken? Is there a point of no return? And that question brings us to our final, and maybe the most important section of all, the critical breaking point. This is where the line between a renewable and a non-renewable resource can get seriously blurry, and the consequences can be devastating. The critical zone is what happens when our rate of use starts to outrun the resource's natural ability to bounce back. It's the tipping point. At this stage, the whole system can just collapse, and natural recovery simply fails to happen, even if we stop what we're doing completely. This is such a powerful way to think about it. Once a flow resource enters that critical zone, it's not renewable anymore. We are essentially mining it, just like a mineral. We're draining a finite stock that is not going to come back on any timescale that matters to us. And the consequences are just severe. For living things like fish stocks, populations can get so small they just can't reproduce, and that leads to extinction. Gone. Topsoil that's lost to erosion might never recover naturally, and our underground water reserves, the aquifers, once they're depleted, we could be talking hundreds, even thousands of years for them to recover, if at all.
Which brings us right back to where we started. Remember? Resources are defined by man. We see now that our actions don't just define what a resource is, they determine whether it even remains a resource for the future. So, knowing that this critical breaking point exists even for our so-called renewable resources, the final question really is for all of us: how are the choices we make today going to define what's left for tomorrow?